Hello, I am Aldolor5, and I'll show you today the new RNG seed finder that I just released in Pokemon Colosseum. This is a proof of concept, so it's not a full project. I'm going to use this in a full project, in a full GUI interface and everything, but I just want to do a video tutorial on how to exactly test this, and how the procedure goes, and what it implies. So essentially, I figured a way to find the current seed with 100% certainty in Pokemon Colosseum, which, if you don't know what a seed is, it's the number that is used for RNG. So essentially, RNG is just a sequence of number, and on this game, it's pretty simple algorithm to use it. And if you know your current seed, you can pretty much predict everything from now on, considering you know how many times RNG was called. And what this allows to do is it allows to pseudo manip the IVs of the starter. Also, this doesn't focus well. It will allow to manipulate the IVs of the starter, because on the naming screen the RNG advances at least once per frame. So you still have to hit a certain frame, but you know what IV you will get depending on the frame you hit, which also tells you the likelihood you'll hit a good one, and it allows you, because you know your currency, to change this likelihood by purposely calling RNG. So that's essentially what this is, and I'll just walk through the process of how this is done, because it's not that hard to do. It's just the process behind is a bit complicated. So this is why I put very clear instruction on this, but we'll just walk through in a video here. So here it asks for GameCube or Wii. This works on both platforms. The only thing is, on Wii, this will be slower because we're going to use the clock soon, and the clock is faster on Wii. So say for a given second, the clock will advance more on Wii than on GameCube. It's about 1.5 times faster. And we use the clock because the initial seed of the game will be used will be the clock value. The most precise part of the clock value. So the number of ticks per second matters here. So on Wii it's going to be faster. So it's going to be slower, but it does work on Wii. I just haven't tested it because I don't have a Wii now, but you can also test it. This should work. If it doesn't, just tell me. So here I have a GameCube here, so we're just going to use GameCube. If I can get there we go. Okay, so here is where you will use the clock, and there's a setting here. So what I did is, there's a time between the time you set the clock to January the 1st, 2001 at midnight, and the time you boot the game, which is important because it matters for what seed you'll get at the beginning. So what I did is, on Dolphin, I recorded with frame perfect input what seeds you would get if you were frame perfect, if you did frame perfect. So I did this as a minimum. You cannot get lower than this, in theory. The margin of error is the number of seconds you can waste maximum from that frame perfect time to the time you actually boot the game. So here, I recommend 3 because I tested with 3, it was low enough, and on my test it was consistent. But say you are 5. This means you can waste up to 5 seconds starting from frame perfect input. So you can waste a lot of frame if you put with 5. But with 3, that's... Whoop, I pressed enter by accident. It's fine. It's going to work. So with 3, you can waste up to 3 seconds, which is quite a lot. Because wasting 3 seconds on the menu, you quite need to be slow, from what I could test. So we're going to go with 3. Okay, concept with pre-calculation. Now, I'm just going to run through this because it's going to take a while, but I'll explain in the meantime. There's RNG calls, because what we're going to do to find out your seed is you're going to check what you get when you go into battle now and generate a single battle team in the ultimate difficulty. We're going to do this over and over. But before you even generate the first one, there's a lot of calls that happens that this program has to run through them once and only the first time. So what I decided as a performance optimization is offload the number of calls it does. So you calculate the number of RNG call it will do before that first team generation into a file. So for this, for GameCube and 3 seconds of margin of error, it's about 231 MB. That's not too bad, but if you put 5 seconds, I think it was like 500 MB something. The higher the range, the higher this file is, and this file does take a while to generate. Like here, it took about a minute or two, and it just got done. But it will significantly speed up the thing. On my test, it was like you cut 20 seconds. It might be even half of it because, yeah, actually, it might be even half of it. So it's a huge performance gain to preload this file. And it can be reused as long as you use the same setting. So GameCube with 3 seconds of margin of error. As long as you use these settings, the program would just detect, oh, there's a file. Do you want to use it? That's what it will. That's what it will happen. So here we definitely want this. But yeah. By the way, you can disable using the RTC here if you want to test it. So it's going over to 4 billion range. Which means you don't have to use the clock, but you cannot really do a pre-calculated file because that's 8 gigabytes. You don't want that. In fact, it's even worse because it has to put this in RAM when it's going to do its thing. So you need at least 8 gigabytes of RAM free. That's not going to work well. But it's going to be very slow, like 10 to 20 minutes, which is why this will now ask to set the clock and everything. So there's a long series of instructions that you can read, but I'll just do it in this video so it's clear what you have to do. So you need the disk inserted, then boot the console. And now because this is on GameCube, I have to, and I don't have the sound. 1 second. But you have to go to the main menu essentially like I did. 1 second. Oh, it's off. I think you hear? Okay, now you hear too much. Okay, long story short. This is a word setup. This is not a CRT. I have a composite to VGA converter, which is kind of crappy, but it will work for a purpose. And for the audio, I basically put the audio through an adapter that goes through my line in of my PC, which is kind of crappy, but still it works. And I have these headphones to serve as speaker, basically. The clock. What you have to do is go to the time setting, set the date to January the 1st, 2001, and then set this to midnight. Okay. As soon as you confirm this, even before you hear this sound, you can exit out the menu. Literally the frame after you can. But as soon as you confirm this, you want to boot this as fast as possible. You want to get there and press start as fast as possible. And like I said, because we chose, a bit above the thing, because we chose 3 as a margin of error, you can waste up to 3 seconds doing this, which is quite a lot. There's one thing I have to mention, because it sounds simple enough, but there's one detail. Here's my controller. You want to do this. Because if I don't let my stick neutral... Okay, this is a bit weird, but... Okay, 1 second. Okay, this is weird, but... okay, what if I exit out here? Okay, there we go, okay. You notice there was a small delay. And that happens... I'll just put my hand here. When you don't keep your stick neutral. between that transition. If you don't keep your stick neutral, there's going to be a delay before it can go up. And that delay, I tested it, and if you did have that delay, it's going to be very inconsistent. So what you want to do is not this. You want this. This is what you want. If you miss it by accident, just go back and set the clock again and try again. That's all you have to do. So, I'll do this with one hand, which is a bit difficult, but it's going to work. Whoops. There we go. This is going to work. So, the program asks you to do this, and I do talk about the little stick thing on... Oh god, I have to lower this because this is awful. Okay, that's better. I do talk about the GameCube thing. If this can focus... can it focus? Please focus. Okay. God, you do not notice a small delay when navigating the cube menu to select the game disc. So, yeah. So what you want to do, now that the game is booted, your seed is already generated, by the way. You don't have to worry about the clock. As soon as you see the Nintendo logo, even before that even, the seed is generated. There's some RNG call that happens here, but you don't see them. And now you go here. This is where we can start to generate some stuff. Little thing, never exit the Battle Now menu when you're doing this. Just back off the confirmation screen and go back to it again between each phase. So what you want to do, if I can get this thing, is please enter the number that matches the name of your generated trainer. There's only 3 possibilities. Here it's set, so you say set 1. Please enter the number that matches the leader of your generated team. It's Meganium, so here it's 4. And then it just drew its thing. So here it's simulating about 121 million seeds. It sounds like a lot, but you're going to see it's going to be done in 10 seconds. 9 seconds even, that's actually a new record. With pre-calculation, because we generated a file earlier, with 4 threads. Here's a thing about this program. It scales very, very well with the amount of threads your CPU have. It's more than the amount of core. If you check the amount of core your CPU have, do multiply it by 2 if it supports my hyper-threading. Here, this is a CPU that has 4 cores, no hyper-threading, so it only has 4 threads. But the more threads you have, the definitely faster it will be. Like on 8 threads, this will be done in 5 seconds. I'm not kidding. I tested with a 5-second margin of error. This is about 20 seconds. And I know most people has 2 threads, so if you're one of those people, just multiply this time by 2. So it's about... maximum it should be 50 seconds. With 2 threads and a margin of error of 5 seconds. But to be honest, use 3. 3, I tested it, was quite consistent. Okay, and now there is... 1, 2, 3... 3 million results still. So we still have to do another pass. So go here, okay. Again, never accept the battle and never back off the Battle Now menu because it's going to screw up everything. So name Wes with Ente. The next pass, by the way, are going to be instant. Like, I can just... Thomas with Suicune. I know this by heart because I've done this so many times to test it. Okay, Thomas with Meganium. By the way, if it generates the same thing a lot of time in error, don't worry about it. Just enter the number. Because, like, I think we just did it 3 times. It's already at 241. But you want only 1 result at the end. Okay, Wes with Heracross. 7 results. Okay, I think about 2 to 3 passes left. Wes with Raikou. Oh, done! And here's your seed. If this can focus... This thing has a lot of problems. Okay, anyway, I'll just read it. It's 66DD 165BF. So that's our seed right now. This means that this program succeeds. So right now, as the state of the game is, this is our seed. You know the program failed if it says 00 result at the end. It would say couldn't find your seed. In that case, either redo the procedure, make sure you done everything correctly, or the program is wrong. In that case, you should definitely tell me, because I tested this a lot of time and it did work. At least on GameCube, it worked pretty nicely. Okay, I'm just going to shut down this sound because it's getting a bit annoying. 1 sec. I can just press it. Okay. So that's it. That's all this program is doing. The reason I didn't do the rest, by the way, is this is the procedure a speedrunner will have to do on each run. Each run, they will have to do this. So it's important that they are aware of it, because if you are okay to do this once before each run, and it tells the likelihood you'll get a good starters, and it tells what you'll get depending on the frame you hit, then that's good. I'm going to continue with this project. But the reason I wanted to do a proof of concept is so that people are aware what we're going to deal with. So that's essentially it. I released this entire piece of code. There's like 300 lines in this file. The actual, if I go here, this is the actual RNG code that I had to reverse engineer. I well commented this code, by the way, if you want to check it. I'll link both the binaries in Linux and Windows. macOS, I'm sorry, but I don't have the tool to build on it. Maybe try to use Wine in the Windows version, but I can't really build on Mac. You could try, because there's a CMake file which should work on Mac. So yeah, it's well commented. There's a lot. This is all the RNG stuff that I had to reverse engineer. It's about 300 lines of code. So it's quite a complicated process under the hood. But as you can see, it's quite simple to do. You just have to do it correctly and follow the exact instruction that I'm telling. So this will be it. I'll be linking the code and the binaries in the description. Thank you.